Samir, please tell me what is the basic motivation behind your work?
So, well, to say as a matter of fact, I have been thinking for so many days that sun technologies are really the breakthrough technologies, and people work at the cutting edge there. So we should use these technologies, particularly as students, to build up our fundamentals basically. And with this purpose in mind, I did a very small project or just a work, as I would like to say, by which we can make a basic study of computer networks operation. Here I use computer networks and network level virtualization and OS level virtualization using zones. So by using these two technologies, what we create is a virtual network machine, and by combining those virtual network machines, we create a virtual network. And I have written utilities for which we help the user at a basic level to know how various protocols like IP, TCP, UDM, UDP, ARP, RARP and all those things, they work on the network. And it will also help the user to just jump beyond the text and see for himself what is happening. And by using my programs, he can think in the future, yes, I can do a better network analysis than this job. Of course, there are so many tools available in the market.
It would be better if you show me the demo of your project.
So basically, for the purpose of a demo and in less time, what I have done is I have created a source which is a non-global zone, and here is the global zone. To the source, which is the non-global zone, I have assigned VNIC 1 and IP address 10.0.0.2, and in the global zone I have assigned VNIC 2 with IP address 10.0.0.1. Both VNIC 2 and VNIC 1 have been created on an Ether stub, and Ether stub, according to Project Crossbow, is the simulation of a cable. Now going to running my programs, first of all I want to know what happens when a TCP connection is being created. Basically, when a TCP connection is being created, so first the client sends a SYN packet to the server, and the server sends a SYN plus SEK segment to the acknowledgement, synchronization plus SEK segment to the client back. So first of all, what I did was I run the Java my server with a small Java TCP sample application program. Now I run the Java server on source, and I just run the client program on the global zone. So here it shows that the connection is established. Now whatever I write on this terminal will be visible on the client. So basically, first of all, what happened here was that when the connection was being created, so a IP packet was sent in which the protocol was a TCP segment. Here there was a synchronization segment, which means that the client is sending a synchronization segment to the server. Now, so you see here from the global zone to the source, so what the reply comes from the source to the global zone. Okay, so what is that? This is a SYN plus SEK segment, means the server gives an acknowledgement that yes, I have synchronized the sequence number and the acknowledgement is valid. In this way, the IP connection has been created. Now for this, after this, when I wrote something in the server terminal and which came in the client terminal, that those things have been also done. So whatever we are doing connections, whatever we write on the server terminal comes on the client terminal, and the same is being sniffed by the program IP sniffer. So in this way, by using Crossbow, we could know how a TCP connection was being created and how client and server interact with each other by sending TCP segments. What is the process of a basic TCP connection? So I have done this basically for IP version 4, and I have not done for IP version 6. This may be a part of future work. Idhar stop kar.
So have you written this for only TCP or ICMP also?
So basically my purpose in this for creating, I have created programs for sniffing Ethernet headers, ARP headers, IP, TCP, UDP and ICMP. For example, I can show how an ICMP operation is being done. So for example, when I ping from the global zone to the source, and it shows that the source is alive 10.0.0.2, which the IP address I have assigned to the source. Thing is that when I run the IP sniffer program here, inside the IP datagram what is being sent is a ICMP echo request from the global zone to the source. So this is a echo request ICMP packet which is being sent inside the IP datagram. Now what the source replies is that yes, I am alive, saying it sends a ICMP echo reply segment. So in this way I found that yes, I can read ICMP packets also. Now I can extend this program to see if some other messages of ICMP like host unreachable or some time to leave has expired or something like that. Now come to the details of the IP header. It reads completely the IP header, the size of the packet in bytes and the IP header length, the IP version and the identification number, whether the segment is to be can be fragmented more or not, what is the time to leave and what is the protocol that is being protocol header inside the IP datagram, the IP header checksum and everything. So I have just mentioned options here because in IPv4 we don't normally use options except in TCP, which is means if we can write programs for TCP which can get the TCP options, then it would be a very good way to analyze the network. So basically this thing also can be done. So in this way we just came to know that what happens when a host pings to a remote host. So that is, yes, a beginner could learn that yes, I am sending a ICMP packet. So in this way, by using Project Crossbow and these small programs, we could learn how the IP datagram is being done, what are the various fields in the headers of a IP datagram, what are the protocols that are being implemented inside the IP datagram, like ICMP, TCP, UDP and all those things, what are the various header information of those things. So in this way, by using Project Crossbow and programs, we could know at a basic level at least what is being done when a computer works on a net. So by using this program on the internet, whatever your transactions are being done, you can know everything. So because of lack of time, we are not able to give the demo on Ethernet and ARP. So, but with these programs you can do the same also. Programming is also quite easier because at a basic level, but tough things will come when we go for finding the congestion window size of the TCP and for finding the increase in sequence number, how TCP responds to congestion. For those things, the best thing is that we create the congestion ourselves. The best thing about network analysis is that there is no particular theory to which you can follow. So you have to create your own theory, that is because of your own experience only. So this much.